And they take it, it's, you can take German in school, and then you can take Estonian. It's the next language. Let's see, it's coming along. Here we are. It'll find it. It's just circling through all of its, and it didn't find it. Okay. It was working before, and no, give it a second. And the next one is the winner. There we are. Very good. Technology works. So I'll be talking this evening about the brave new world of IT. So a bit about me. I'm president of ZapThink, a Novell Technologies company. ZapThink has been around for about 12 years. We started off as an industry analyst firm focusing on XML, then web services and service-oriented architecture. And then recently our shift has been focusing more on the architect, put together the 4-day licensed ZapThink architect course that I'm running here in Estonia. That's what, that's why Dev Training brought me to Estonia, as well as our 2-day cloud computing course. There's my and then there's my 4 books, and I'll be giving away a copy of the Agile Architecture Revolution today, except I left my copy in the hotel, so whoever wins it will have to figure out how to get it to you, but it is here in Tallinn, so it's not going to be too tough. We'll just have to figure that out. But I did bring the posters. Hopefully everybody got a copy of the poster. Okay, so let's talk about enterprise IT, and we'll start with the current state of enterprise IT, which is the dark side, right? With Darth Vader, right, and the Emperor. Well, that's not the Emperor. That's the other Sith Lord. Because what is in enterprise IT? Well, you have big, expensive, monolithic applications. All of those legacy applications. They're partition intolerant, right? They work in individual partitions. They don't work well in a distributed environment where the network might be unreliable. If you have transactionality, you would have ACID transactionality, like you have in an enterprise database that requires expensive technology. So you have very expensive systems, and you have a single point of control in enterprise IT. So for all of these reasons, enterprise IT is centralized, it's expensive, it's difficult to work with, and inflexible. So what's happening though in enterprise IT is cloud computing has come along, and it is changing the whole way of thinking about enterprise IT. Because cloud computing comes from the world of web scale, horizontal scalability, distributed applications that are geographically distributed, and a whole new way of thinking about provisioning IT resources. So in particular, cloud computing brings the challenge of elasticity to the enterprise. The ability to scale up dynamically in an automated, rapid fashion as capacity requirements go up, and then scale back down when you don't need those resources, again, in an automated fashion. So if you're building some sort of big legacy distributed or some sort of big distributed application, you're used to saying, well, this has to run on a certain number of servers, and having some idea how many servers it's going to run on. Well, now you don't know ahead of time, or you have more, you might have fewer, depending upon the capacity needs of your application at the time. So it's a new way of thinking about how to build scalable applications. So the cloud also introduces a new way of thinking about dealing with failure. When in a traditional enterprise environment, you want to avoid failure. It's all about high levels of uptime. Right? If you pay a data center provider, you're going to pay them for so many nines of uptime, 99.999% uptime, and you're paying a lot of money, and then they have all of these technology approaches for guaranteeing that level of uptime. So you're using mirroring, using RAID disks, and you're focusing on highly available systems that are as available around the clock as you can possibly make them. Well, that's not the way the cloud works, right? In the cloud, we expect failure, we plan for failure, and failure happens all the time. Right? In the cloud environment, you have commodity hardware. You have inexpensive hardware that has regular failures. If you provision virtual machines, many times they just don't work properly, or even if they do work, then at some point they may just crash, they may disappear, they may go away, and you expect that. So in the cloud, you're not trying to avoid failure, you're expecting failure, and you have to essentially respond automatically automatically to failure. So the cloud is much more about bootstrapping or automated recovery from failure than it is about avoiding failure. So instead of high availability, we're looking for basic availability. So in the cloud, basic availability means that individual nodes may go down, but your overall application continues to function. So if you haven't architected your application to be basically available, if you architected it so that every bit has to be working for the application to be working, then it's not going to be very cloud friendly. So the challenge of scalability. Traditional enterprise scalability is vertical scalability, right? You need more scalability, you buy a bigger box, you put in more cores, you put in more memory, you put in faster processors, and that's vertical scalability. Of course, you end up with very expensive machines, and it only takes you so far before the machine is as big as you can make it. In the cloud, you're focusing on horizontal scalability. Yes, you can add a bit of memory and you can add a few more processors, but that's not really how you want to scale in the cloud. How you want to scale in the cloud is by adding more individual nodes or virtual machine or storage instances. And you can do that as much as you want. But if your application isn't designed to work on very large number of individual nodes, then it's not properly architected for the cloud. So this is one of the challenges, right? A traditional enterprise app won't work properly in the cloud, won't take advantage of the elasticity benefit of the cloud unless it's architected to scale horizontally. So the challenge of control, right? In a traditional enterprise environment, you have centrally managed applications, centrally managed licenses, maintenance contracts, right? And upgrades can be difficult, customization can be difficult and expensive, and this is just the way you do enterprise applications, right? Difficult, expensive maintenance customizations. Well, that's changing, right? The whole notion of centralized control is breaking down in the enterprise as we start bringing our phones to work. Right? Bring your own device, BYOD. The phones that we have now are computers in their own right? They're powerful supercomputers, and we all are bringing our own computers to work in our pockets, and that's changing the way that enterprise IT has to think about how they control the technology that people in your organizations want to use. So we have this new way of thinking about how to deliver application functionality instead of some big expensive app where you're just providing secure interfaces to your people. Well, now it's an app store model, right? If somebody wants some sort of capability, they'll take their phone and they'll buy it or download it onto their phone, and whether or not you're controlling that. And then we also have the notion of a distributed hypermedia application, which is a whole class of application that is essentially built along the lines of the web. So you do this, all the time in your personal lives, and now that's becoming an important part of your work lives as well, right? You don't think twice about connecting Facebook and Twitter and Instagram and Pinterest, logging in with one, accessing the other, posting an image from Instagram onto your Facebook page, right? This is just the way the web works, is all of these applications work together as essentially a distributed hypermedia system. Well, that whole notion of a distributed hypermedia system is now impacting enterprise IT and how we build enterprise applications. There's no reason anymore to say, well, SAP is this one big monolithic monster and it works on its own, and then we have some other app over here and it works on its own. No, the whole way of doing enterprise applications is becoming a distributed hypermedia architecture following along the lines of the Facebooks of the world. So that's a whole new way of thinking for the enterprise, even though we've been doing it on the web now for almost 20 years. So the challenge of mobility, right? That phone in your pocket is more powerful than the supercomputers from 20 years ago, right? It is an enormously powerful device. From the enterprise perspective, we're used to treating the phone as an endpoint, right? You have browsers on your desktop, you have a browser on your phone, it is some sort of user interface device, and that's really the whole story. We have to secure the user interface, so we have to secure our phones. But if you think about it, that whole model is shifting because the phones are so powerful that they can be a part of your infrastructure instead of just an endpoint device. And this can be a challenge because now security becomes a greater challenge, management and governance become a greater challenge as well. As we move to the Internet of Things, where any device can now be a node on your network, not just a phone, but it could be a piece of factory equipment or a retail point of sale system, or yes, your refrigerator too can be a node on your network. Well, now all of these nodes are talking to each other, and now security becomes a greater challenge, and building distributed applications takes on a whole new meaning. If the distributed app could include your phone and your car and your phone and your refrigerator and your air conditioning, and the list goes on, right? So it opens up whole new realms of possibility as well as whole new areas of risk. So To get a little more technical, I know there's probably some technical people in the room. One of the challenges with moving to the cloud is the challenge of maintaining state information. So let's say you have this big e-commerce application. So everybody has a shopping cart, and you have to keep track of what's in everybody's shopping cart at any point in time. Well, now you want to take that whole e-commerce application and stick it in the cloud. Well, there's a problem, because where do you put all that state information? Well, in a traditional N-tier application, a 3-tier application, we put all that state information in the middle tier. We could write it to the persistence tier, to the database, but that doesn't scale very well. Right? If you have a simple 2-tier app, browser and database, yeah, you can store the information in the database, but those don't scale very well, which is why we added that middle tier in the first place. So we could put our session information there. Whether we use session beans or session cookies or some other mechanism, that's where we typically put that session information to keep track of it on behalf of the client. We can't do that in the cloud. Why? Because that middle tier goes on virtual machines that crash and burn on a regular basis, right? This is the whole point of basic availability, is we're expecting the nodes in the network to fail. So we don't want to put state information there. So where do we put it? Well, we can put some of it on the persistence tier, put it in our database, but that still doesn't scale very well, even in the cloud. So that leaves the client, putting state information in the client. So what do we do? Set cookies? Well, cookies are a problem. Not everybody supports them. People turn them off. So we need a new mechanism for separating out the state information we want to put on the client from the state information we must maintain on the persistence tier in a way that lets us scale and doesn't require us to put state information on the middle tier. So we need a new approach for doing that. So essentially, we want to leverage hypermedia to maintain the application state information. So separate application state from what we call resource state. Resource state is stored on the persistence tier. Move the application state to the client and enable the hypermedia themselves to maintain that state information. We call this hypermedia as the engine of application state, where we have a hypermedia application, and where are you on a hypermedia application? It's whatever web page you're on today. Right, at this moment, and the hyperlinks tell you what you can do next, and that's how you maintain state information on the application. So hypermedia is the engine of application state. Anybody familiar with that phrase? Anybody heard that phrase? Ooh, nobody's heard that phrase. Well, hypermedia's engine of application state is one of the core architectural constraints that form the REST approach. So anybody here familiar with REST? So it's interesting. All these people are familiar with REST, but nobody's familiar with hypermedia as the engine of application state, or HADOS, what we call it. Well, without HADOS, you can't do REST. So if you think you're doing REST, but you haven't figured out this HADOS constraint, you're fooling yourself. You're not doing REST at all. Because what is REST for? It's an architectural style for building distributed hypermedia systems. And you can't do that unless your hypermedia are the engine of your application state. So, but a lot of people who do REST, Restafarians, don't get this point. So the world of REST has this odd kind of schizophrenia, right? All these developers think they're doing REST because they're using HTTP and to build simple uniform interfaces to their software. That's great, that's very powerful. There's enormous simplification of how we build APIs, but that's not what REST is really about, because you're missing the hypermedia part of the story. So REST, what is REST anyway? It stands for Representational State Transfer. You ever wonder what that name is about, state transfer? Well, it's about separating resource state from application state and transferring state information in the messages in the form of representations. So it's moving state around is what REST is really all about, right? And it's a style of software architecture for building distributed hypermedia systems. So now where does REST come from? Well, this guy. I took liberties with his body. Right? That's not really his body. That's Michelangelo's Sistine Chapel painting of God, right? But that's his head, all right. I just stuck his God's body on there. That's Roy Fielding. He is one of the creators of the HTTP protocol. So back in the 80s, he helped create HTTP, so he's one of the fathers of the web. And in 2000, he wrote his doctoral dissertation where he coined the term REST. And what he did is he looked at the web and saw that it was good. The web is good, hence the whole God thing, right? Looked at the web, saw it was good, and figured, well, can we distill the fundamental principles of the web that make it so special into a set of abstracted architectural constraints we can apply to a broader class of distributed computing problems? And that's how he came up with REST. So he looked at the web, and what did he see? Well, by 2000, it was enormous, right? Massively scalable, horizontally scalable, no limit in how big it can grow. It's enormously resilient, right? Servers can go down, doesn't matter. The web keeps working. Networks can go down all over the place. The web keeps working. Right? And it had no single point of control, right? Nobody is running the web. People run different bits of it. Right? The telcos have this bit, the domain name system has this bit, and there's bits and pieces, but nobody's in charge of the whole thing. So wouldn't it be great if we could take those principles and apply them to distributed computing problems in general? And that's how he came up with REST. But REST, where developers like to think it's about the APIs, the programming interfaces. But it's not. It's about the architecture. So it's like the difference between designing a brick building and mixing mortar. If you're a mason, you might be really good at mixing mortar, and you can stick bricks together really well. But if you don't have the design, you're not going to build a good building. Doesn't matter how good a mason you are, you're not going to build a good building unless the architect does their work properly. It comes up with a design for the building, but how it is you're going to build the building to meet your business need. So this is the challenge with REST. You think it's about APIs, and yes, you're mixing good mortar, very simple way of dealing with programmatic interfaces, but the big picture is building hypermedia applications. So this is the challenge of architecture, right? We're running a SOA course this week, Service-Oriented Architecture course, and this is the story of SOA for the 2010s. It's not just about ESBs and middleware and big, expensive, heavyweight enterprise IT. It's becoming more and more about lightweight, REST-based approaches to building services following the hypermedia principles of REST. So it's a whole new way of thinking about legacy systems and how we're going to expose them as services in a lightweight way in the context of this whole new world of enterprise IT that is now cloud friendly. And that's the real key here, right? I started talking about the cloud and it quickly started talking about REST, but they fit together because without REST, we don't have a way of moving state information off of the middle tier, and we need to do that to put our stateful applications in the cloud. So that's our 2006 book, and that's our 2013 book. Very good, okay. So finally on the light side, Luke Skywalker, right? Where the cloud is pushing the enterprise, whether they like it or not, into the world of web scale. Pushing the enterprise to think in terms of horizontal scalability and in terms of hypermedia-based applications. So now we have this whole new way of thinking about how to leverage these new technologies, new approaches in the context of enterprise IT. Okay, so the world of web scale, the light side. So hypermedia-based applications. Now Facebook has been doing it. I mean, you look at Facebook. And think about what they had to do to make that thing work. Right? Everybody goes to Facebook.com, and if you're logged in, you see your own Facebook page. And there's a billion of them. You try to build an application with a home page that has a billion different versions. Right? And it still responds asynchronously, updates itself automatically, and it connects to everybody else's home page. Right? You might have 500 friends and you're seeing 500 updates. How do they get that to work? It's amazing. Can you do that to your enterprise application? Well, the technology is available, right? If Facebook works, we know it's possible, right? And that's now the story of web scale that is impacting the enterprise. So we have partition tolerance, where it's okay if the network doesn't work, if the nodes aren't in communication with each other. That's not the traditional way of thinking about distributed application. You expect the nodes to always be in communication. You expect your network to be up and running. But that doesn't work in the cloud, right? In the cloud, you might have virtual machines around the world and data centers around the world. Who knows if the network is always working properly? Your application has to be able to work even if partitions develop. That is, even if the network doesn't have all your nodes in communication. So we can't do ACID transactionality. We can't commit transactions if the nodes in our database don't communicate all the time with each other. So we can't do ACID, we can do BASE. Right? BASE is a basically available approach to transactionality that's different from ACID transactionality. And we're also talking about a very resilient approach. Right? If nodes go down, they come back up, we're off and running. Right? And this is the way the cloud works. This is the way the enterprise has to work. And no single point of control. Well, tell your boss that they're not going to be able to control the enterprise IT anymore. It's like, whoa, that's my whole job, is just controlling this stuff. But people are already bringing their own phones. Right? The writing is on the wall. Bring your own device is only part of the story. Bring your own cloud. Bring your own everything. Right? It's a whole new way of thinking about enterprise IT. All right, let's shift the topic a bit. Let's talk a bit about big data. How does big data fit into this story? Well, what are big data? Well, it's a marketing term, right? It's a lot of noise, a lot of nonsense. But there's something there, right? There's something at the core of big data. But it fundamentally has to do with change. The way we define big data are data sets whose size essentially is too large for traditional or established tools to deal with. So we do have big data tools, but they are bleeding edge tools that are still in development, they're still immature. The mature tools can't deal with these data sets. So if you think about that definition, it's dynamic, right? What constitutes a big data set keeps changing as our tools mature. The sets keep getting bigger, and it's relative, right? What constitutes a big data problem in one industry or one company is different from another, right? Big data in the world of genomics is very different from big data in the world of retail or in the world of banking or some other industry. So how big data is continues to change over time. Well, what this means is that big data is nothing new. We've had big data since we started having data. Because if big data always means data sets that are at the limit of our ability to deal with them, well, that's always been the case. We've always had those. So this was a big data tool in its day, right? That's the Hollerith punch card reader, right? That was the first tool that enabled us to automate census data calculation. Right? Before that, the census had to be fully manual. People, writing numbers in books and then tallying up the numbers manually or maybe with an adding machine. That was it. Well, now we could put all the census data on punch cards and count them automatically. That was a big data problem in its day. But at any point in time, there was always some threshold to what we could deal with, and the brand new tools were the big data tools of the day. So big data is nothing new. It's been with us all along, and it will always be with us. But what constitutes big data will continue to change. Unfortunately, our brains will not. Our brains can only get better relatively slowly. The big data sets, double in size every 2 years, whatever the number is. Like we have more data in the world today, or more data in the world generated every year today than all the data in the world generated up to 2003 or whatever the figure is. Right? But every 2 years it doubles in size. But our brains don't. Right? At best, our attention span, our ability to process information, micro in a linear fashion, but the quantity and complexity of information is growing exponentially. So at some point, doesn't matter what data you're talking about, you're going to reach this big data crisis point, right, where you just aren't able to deal with all that information. And this is, if you haven't gotten there, it's just a matter of time. This is one of the challenges of big data. So why do we collect big data? Well, it's human nature. Right? In fact, we call it Parkinson's Law, although it's a big data corollary to Parkinson's Law. So I don't know if you remember Parkinson's Law. That's the principle that the amount of available work will expand all the available time. So you ever wonder why you can stay an extra 2 hours at work and you still are busy? It's not like you have extra time, right? Your work always fills available time. Well, the quantity of data fills your ability to store and deal with it. So, back when we had, I remember for my first hard drive was 20 megabytes, and I filled that up, right? Then 100 megabytes, filled that up. Now we have terabyte hard drives. Fill that up, right? Why? Because we can, right? And that's the basic principle here. So this is a challenge, one of the challenges of big data, is we will always collect big data sets, which are sets that push the limits of our ability to deal with them. So, and that's always going to be true. So, what we need is better ways of dealing with change. Big data is all about change. Moving from cloud computing is pushing the enterprise to change. And how do we solve this problem of change? Well, it's not a technology problem. Like, technology alone does not help us deal with change any better. Does not make us more agile. But I love this picture. And see what that is? That's one of those electronic billboards with a blue screen of death on it. It's a real picture. Anyway, okay. It happens, right? Technology doesn't help us deal with change, technology alone. So, how do we deal better with change? How do we leverage technology to deal better with change? Well, here's a starting point. Traditional systems engineering. Whole lot of words. What a system engineering is. I got this off of Incos. That's a system engineering website. Well, what does all this mean? A lot of words. This is what it means. Business on the left, right? Business stakeholder. Techie on the right. So the business stakeholder says, build me something. Here's the requirements. Many steps removed, all the hard work. Techie delivers on the requirements, and the stakeholder's happy. Sort of obvious, right? This is how we deal with technology, right? We have our requirements, we build to the requirements. Very good. Okay, that's the waterfall way of thinking. Requirements are well-defined, properly specified, and fixed, and then we build to those, right? So how well does that work? Well, it's not news. This doesn't work too well, right? Because requirements are never completely specified, never fixed, right? And never properly understood. So, but this is nothing new, right? In reality, this is the way it typically works. Build me X, okay, deliver on the requirements, and for one reason or the other, the stakeholders aren't happy. Usually because requirements have changed, requirements are not properly communicated or understood, or of course, the business stakeholder looks at what you built, little twit there, looks at what you built and says, yes, that's exactly what I asked for, but now that I look at it, I don't like it. And I mean, stakeholders have said that. Okay. Well, of course, this is nothing new. This is why we moved to the Agile Manifesto, right? Agile approaches to software development. There's our Agile lady doing her stretches at a bus stop. I don't get that, but anyway, that's our Agile lady. And the Agile Manifesto, right, the core principles for all of the Agile methodologies, extreme programming, Scrum, and all the others. Essentially, these 4 principles. The whole point of the Agile Manifesto is to build better software. So we want to be more customer focused. We want to focus on software as a product of human capability. Tools don't build good software. And we want to focus on dealing better with change. So if the plan changes, we want to respond to change instead of following the plan. Okay, we've had the Agile Manifesto for a dozen years now, and if you've figured out how to build software in an Agile way, you'll have better software because it deals better with changing poorly understood or just poorly communicated requirements. So, and we build better software as in better, more what the customer wants. So is that good enough? Does that make us more Agile? Well, it's better than nothing. We have this iterative approach. Right? Requirements go in, and because we're iterating, because we're involving the stakeholder on the team, we're better able to build good software, but we still have a problem that we have to deliver the software at the end. Right? This is a software methodology. So we deliver the software, and at that point, it becomes instant legacy. Right? Because it's deployed software, and requirements continue to evolve after we deploy the software, but especially in the enterprise environment where it's one of many different things, right? It's not just a standalone piece of software, but it's part of this big, complex environment. We have this difficult problem. Right? It's difficult to upgrade, difficult to change, difficult to customize. Right? If you want to take deployed software and update it, you have to go through a whole new update cycle, and that means going back to the drawing board, figuring out your updates, and now everything else is going to break that's talking to it, so you have to update those pieces as well, and it's instant legacy. Right? So building software in an Agile way alone does not make us more Agile. Right? Because the software itself, just because it was built in an Agile way, is not any more Agile than traditionally built software. Right? Because this is what we have. Right? Requirements go in, and yes, we might take an Agile approach to create perfectly good software, but requirements continue to evolve. Change is constant. So we have to come up with a new version, and that is every bit as difficult as it was before. This is what we really want. The business is telling us something new. So they don't just build to these fixed set of requirements. They're saying, build me an Agile system, a system that helps me be more Agile, helps the organization be more Agile. So now out comes working software, and if we have new requirements, the software is able to respond to new requirements without having to change the software. Wouldn't that be great? Software that responds to change as a built-in function of the software. Here's the problem. Business is telling us building something Agile, and what are the techies saying? Huh? How the hell do I do that? Right? How do I build software that responds to change? Right? Well, that's the challenge. That's the challenge of service-oriented architecture. How do we build reusable services? Well, what is a reusable service? It's a service I build today that meets the needs in the future, even though I don't know what those requirements are. Right? That's what it means to achieve reuse. Right? It means building software that responds to change. Well, we have to figure out how to do that, right? The missing link is business agility, the core business driver for agile architectural approaches like SOA. Business agility, right, being able to respond to change, or also leverage change for a competitive advantage. That's what we mean by business agility. And somebody tweeted something about agile architecture, it pops up. But the problem here is this is a property of our organization. We want our organizations to be more agile It's not a technology problem with a technology solution. It requires considering the whole organization, both the technology and the people, because we want the organization to be more agile. So, on the one hand, business agility is a requirement for our software. The business is saying, build me a system that responds to changing requirements, so I don't have to keep changing the software every time I have new requirements. So it's a requirement, and we have to treat it like other requirements. We have to analyze it, right? To figure out what it means to us and how much the business wants to pay for. That's the analysis. We have to provide traceability. So at the end, when we deliver an agile system, we have to test to see if it's sufficiently agile. Is it as agile as the business wants it? Right? That's traceability. So it's a requirement like other requirements. But it's a special kind of requirement because it applies to other requirements. Right? Business agility says, build me a system that responds to changing requirements, and that's the requirement that talks about other requirements. We call that a meta requirement. So that meta prefix means something that talks about itself. So a meta requirement is a requirement that talks about other requirements. And business agility is now a meta requirement. So where is the business agility? Well, it's not in the technology, because the organization has to be more agile. We can build flexibility into our technology, that's part of the story, but business agility is talking about the organization. So it's not just the technology, it's also the people. Yeah, you see what she's doing white out on the screen. I think you have a grandmother like that. They use computers now, but they don't quite get what they're all about. Okay, so here's the challenge, right? If you're only architecting the technology, you're missing the big picture, right? So here's a system of systems called traffic, where the component systems are made up of technology, people, systems, right? The cars and the drivers. But the behavior of the traffic is essentially property of the system as a whole, of all the cars taken together. But if all you're doing is thinking about the cars, and you're not thinking about the people, you're missing the picture of what traffic is all about. Architecting the technology alone is insufficient, right? Because what do you get when you take traffic and subtract the people? You get a parking lot. Very different system, very different behavior, right? So, and this is where a lot of architects go wrong. They say, well, I want to build more agile software, so I'm going to focus on the technology and use agile approaches for building better software, but they're not going to make the organization more agile because you've missed the bigger picture, which is that you have to architect the people as well as the technology. So that's the challenge now of the agile architect. How do we architect people? Right? Well, it becomes a focus on governance more so than integration. And how do we deal with establishing policies that drive human behavior as well as the behavior of the technology? What? Oh, is it off? Oh, fell off. Oh, this is only for recording. Sorry about that. We didn't miss too much. Okay, so how do we architect the people? Well, we focus on governance. But this is a whole new way of thinking about governance. Establishing policies for both human and technology behavior, and then trying to do our best to automate those policy-related processes, automating the communication and enforcement of policies. This is what we call next generation governance. And it's right on the poster, right? In the complex systems engineering quadrant, which is essentially what we want to think of the organization as, a complex system that exhibits business agility as an emergent property. How do we get that to work? We focus less on the technology, focus more on the people. How do we do that? By focusing on governance. So governance is the story of SOA. Governance is the story of cloud. Governance is the story of mobility. But how do we solve the BYOD problem? Through better governance. How do we solve the fact that anybody can provision a cloud instance, pull out a credit card, and there you are, you're off and running? Well, again, it's a governance challenge. But it's not your traditional governance. Right? Governance is a term we've used in the organization for many years, and it's been sort of one of these big challenges we haven't really got our arms around. Right? The business people think about governance, risk, and compliance, and they're thinking about regulatory compliance and broad legal risks. And then in the technology, we think about architectural review policies and firewall policies and things like that. But now we're talking about having a better way of looking at governance that is largely automated and largely iterative, and becomes now a key part of how we drive our whole organization. So, why do we need this? Well, the more powerful our tools, the more dangerous they are, right? That's why we don't give power tools to children, right? Because they're dangerous, right? So now we have more and more powerful tools, whether it's our smartphones, whether it's our cloud instances, or it's our services in a SOA context. We're empowering a broader range of people. Well, the better we do that, the more we need governance to establish policies for how people use all of this technology. So it's becoming an increasingly important part of the enterprise IT challenge. So here's an example. Here's how SOA governance is supposed to work, right? We have this notion of a policy in the SOA governance world, and that policy might be written in XML. It could be a WS policy, formatted policy. You can write them in JSON or some other format, but it's some sort of metadata representation of your policy. So it could be a security policy or a routing policy, transformation policy, that kind of thing. So what do you do with it? Well, it's a metadata representation. It's some file. You put it in your registry repository. So now you can manage it, you can version it, you control who deals with it. And when you're ready to enforce it, you send it to your enforcement point. Could be your ESB or your XML appliance or your identity management system, whichever the appropriate enforcement point is. And that's where you enforce the policy. Okay? So this is SOA governance, right? Creating, storing, managing, communicating, and enforcing policies. But when you meet as an architecture team, you figure out how you want to do all that. Right? What is your policy for doing SOA governance? What is your policy for dealing with policies? Well, we call that a meta policy, right? Meta, same prefix, policy for dealing with policies. How you do governance is now a set of meta policies that your people figure out in order to manage how we go about creating, communicating, and enforcing the policies. So we have two different kinds of policies. We have the policies at this level, which have XML representations. We can automate their enforcement. And the meta policy level, which is more for human interpretation and human enforcement, and has to do with how we deal with governance. So we have this pattern developing. We have requirements and meta requirements, where the meta level deals with change. Policies and meta policies, where the meta level, again, deals with change. Because the power of this is the ability to change the policies. We change a policy up here, it changes the behavior of our whole infrastructure. We can change the routing rules, change the security rules. We can do that simply by changing the policies. That whole thing is now SOA governance. So meta requirements, meta policies, and meta methodologies. If you look at the Agile Manifesto, that fourth principle, responding to change over following a plan. What if your plan is to do Agile? Your plan is, oh yeah, we're going to do Scrum, that's our plan. Right? So we're going to be Agile, right? Well, now let's say there's some sort of change comes along, and the change is, well, we're doing Scrum, but we don't like retrospectives, so we're not going to do them. Right? Well, retrospectives are in the Scrum book. We have to do them. That's what the Scrum book says. But the Agile methodology, Agile Manifesto says you have to respond to change. If there's a problem with that part of Scrum, throw it out, right? Because you want to be Agile. You have to respond to change over following a plan. So that's a methodology for creating or changing a methodology. Right? Scrum isn't about following the rules of Scrum. Scrum is about being Agile, which means you have to be willing to change the rules of Scrum. Right? So it's a methodology for creating a methodology. So there's a pattern here, and it's a pattern for building an architecture that deals better with change. That's the constant theme here. So anybody recognize this guy? Little math trivia, math history trivia. I usually get somebody in the room that recognizes this guy. That is Gottfried Leibniz, the inventor of differential calculus. I really just put him up there because I love his wig. They should bring back wigs like that. Wouldn't it be great? My bald spot would be hidden. It'd be lovely. But anyway, he invented the mathematics of change, right? And that's what we're talking about here. Thinking at the meta level is dealing better with change as how we do architecture. So instead of architecting the things themselves, we architect how the things change. And that's what we mean by Agile architecture. So we have the meta, we have the regular level and the meta level. So meta policy is how we deal with policies. We want to automate the policies, so we have a meta policy. So what if we want to automate that? Well, we better have a meta policy for that. Oh, well, what if we want to automate that? Well, now we need a meta policy, right? Well, this is called the Hall of Mirrors problem. And you have to watch out for this because it can get you off into the wrong direction. If you think about the Hall of Mirrors, though, there's only two mirrors. Right? The infinite tunnel effect is an illusion. It's not really there. There's no real tunnel. It goes on forever. It's really just two mirrors that are facing each other. The same with this meta problem. We have the regular level and we have the meta level. Just those two. There's no meta you have to worry about. So the regular level is what we want to automate. The meta level is how we go about doing that automation. so as to support change, and that we deal with at a human level. We're not worried about automating the meta level. Okay, so how does cloud fit into this? Well, this changes the equation as well, because instead of manually provisioning your IT infrastructure, you've now automated that and pushed the responsibility for provisioning and configuration to your users, who can now provision their own instances and set up the whole cloud architecture themselves in an automated way. So we've really increased the risk of screwing things up, right? In fact, this has happened, right? In fact, there was a story read just about a month ago that over 60% of Amazon S3 instances, that's a simple storage service, their object store, over 60% of them were available on the internet. Right? If you knew the URL, you could go get anybody's object, no security, no nothing. Right? Anybody in the world can just download them. And there was this big hullabaloo. Amazon's not doing their job. They should be securing the S3 instances. This is all this corporate data. There's no, Amazon's really screwing up security. That wasn't what was happening. Amazon was doing everything right. People just weren't turning it on. Right? The security was there, but people weren't using it properly. Right? This is the problem, right? If you don't know how to use the tools, if you don't have proper policies, proper enforcement, then you're just asking for trouble. But there's nothing wrong with the cloud. The cloud is empowering users and giving them the responsibility to take care of these things for themselves. This is the need for governance. So traditional provisioning and traditional IT environment is done manually. Right? Some guy, like this guy, sets up the servers and configures the servers and installs them. Now that's all automated. Right? So we've shifted the whole responsibility to the user. So the cloud also requires us to think in an elastic way. We can't just think about, well, we need 12 servers for that and 10 servers for that. No, we just say, well, we need some number of servers. We don't know what it is. We'll just set it up to auto-scale. Right? So we build an application. It might run on 2 or 20 or 200 servers, and it might be different every day. And we don't know. We don't care. Right? Because it's all fully elastic. Well, if you always have enough servers, no matter how many you need, you have the illusion of infinite capacity. It's a whole new way of thinking about enterprise IT infrastructure. Well, it's now infinite. It's not really infinite, but you have this illusion of infinite capacity. So, but the missing link to all of this story, whether it's bring your own device, whether it's service-oriented architecture and automated governance, or moving to the cloud, the missing link, it's all about agile architecture. So what's at the center of the poster? Well, it's no mistake that the poster follows a target metaphor. At the center, at the bullseye, is continuous business transformation. That's the goal, is to support continuous change as the natural state of our organization, the natural state of business. And that's what we're trying to achieve with agile architecture. All right, so the book giveaway, I need business cards. So pass this around. If you have your business card, drop it in. Okay. Did anybody bring business cards? Do you have business cards in Estonia? There we go. We got one. We'll pass that around. I guess what you could do, though, is, well, no, that's not going to work. Business card, or I guess a scrap of paper with your name and email address. You need your email address. Consolation prize is a LinkedIn invite. So that's what I do with the cards. So I send LinkedIn invite. So not the end of the world. I'm not going to send you spam or anything, just the LinkedIn invite. And if you remember the book, I forgot to bring it. So we'll get you the book. It's here in Estonia. It's just comment it away. Okay, well, while this is going around, any time for questions? So we've got to have questions.
Do you have some kind of example of changing the company of the agile business, or a company that transferred from doing agile works, but now they are doing agile business also?
Well, the examples are still sort of in the works. More and more organizations are figuring out the importance of governance and supporting more agile approaches to enterprise architecture. It's hard to come up with any particular names that are good stories, but it's a lot of organizations are currently struggling with this challenge. What isn't happening that much is putting the pieces together, thinking that the mobility problem, the architecture problem, the cloud problem are all different facets of the same problem of how we deal better with change. And that is still a challenge that organizations are just trying to get their heads around. So there aren't a lot of bad examples. Maybe I'll find one in Estonia. Other questions? Oh, come on, there's got to be some questions.
Maybe you can tell us what has been the best question so far. Give us
You know, I don't know. I mean,
some good questions.
everybody has different questions.
Because you gave so much information, you can't
Yeah, covered a lot in 45 minutes.
Yeah.
Well, I mean, I guess one question that's going to be interesting is how does this relate to the topic of lean startups? Our next topic.
Exactly, I just wanted to ask, like,
No, I knew you wanted to ask that.
fit into that.
Well, I mean, you know a lot more obviously about lean startups than I do, but a key part of the story is to take an iterative approach, where you're working in an area of lack of knowledge. You don't know what the right business is to build, so you take an iterative approach and build the very minimum successful, minimum viable business, and then you continue to repeat. So it's all about dealing better with change. So this is one of the challenges, is how do you architect an organization to deal better with change? And wouldn't it be great if we could do it from the beginning? Right? So many of us are involved in enterprise IT. I focus on enterprise IT, where you already have a mess. You show up at work and there's already a mess, and now the architect has to help try to clean up the mess. But that's not how you architect a building. You don't show up with this really crappy building and say, oh, well, now we need architecture. They'll clean it up. No, I mean, you try to architect a building at the beginning before you build the damn thing. Wouldn't it be great if we could architect a business that way? So maybe the principles of enterprise architecture apply to startups. We can architect this whole enterprise from the beginning. Well, unfortunately, it doesn't really work that way, right? And that's not the appropriate use of your resources when you're building a startup, because enterprises aren't really architected. They're grown like a plant. Right? You start with a seed, you give it a little water, you give it a little sunlight, hope it works out. If it starts dying off, you maybe move it around, give it a little fertilizer, right? You don't really know what's going to work, and you try a bunch of different things, and hopefully you'll grow a nice plant, right? So startups are really more grown than they are architected. So sort of ask the question, well, is there such a thing as enterprise architecture at all? Or is that just sort of a bad name for what we're trying to do? Cleaning up the architecture mess in the enterprise. Well, if it really was enterprise architecture, we would start at the beginning, but that's not really what we want to do. So anyway, everybody done?
I have a question maybe.
Yeah.
Architecture is frozen music, so you can see it.
Frozen music?
Yes, this is one of the terms for architecture, and you can see it. And if it's beautiful, so you can straight away understand what is beautiful. So how you can see the beautiful IT architecture?
Well, I wouldn't describe architecture as frozen anything. In fact, change is built into the definition.
Yes, but music is not, music is always changing. So music, you cannot freeze the music at all.
Oh, so frozen music is a contradiction.
But exactly.
Right. Okay, well.
You can see.
Well, I guess it's a contradiction, because what a lot of architects do is they try to freeze the music, right? They say, try to draw this diagram. This is your architecture, right? Here's that architecture, science diagram, or your job architecture, your security architecture. But that's never your architecture, because change is built into the definition of architecture, right? If you have a diagram on a wall, at best that's a snapshot in time of your architecture. So architecture has always been about dealing better with change. But a lot of architects haven't really gotten their heads around how to do that properly, so they're trying to freeze the music, right? And that's not how to do music, right?
Okay, well, the other question also. Okay, if there is such a big mess everywhere, and we as a human can only start to normalize things only when we can see it. So how we can see this mess, what is happening right now with big data or with all this cloud scalability or whatever. So how we can see it right now and start to organize it. What is the tools? What are the tools that we can start using today?
To get a picture of your current state, is what you're saying.
About our architectural mess.
Well, I mean, I don't know if there's any particular tool. I mean, there are a number of different tools that can help you get visibility into your current state of your architecture.
The tools is something that just helping us to do something. So I'm not talking about tools. I'm talking about kind of ways.
Yeah, I would say that, there is no perfect answer, right? There is no perfect tool that gives you a complete picture of the way everything is. So you're working in an environment of lack of information. And the best thing to do if you don't have all the answers is to take an iterative approach, right? Agile methodologies are fundamentally iterative because that's a better way of dealing with poorly understood requirements. Well, architecture should be iterative as well because you're dealing with a lack of information about your current state and about the best practices for achieving solutions to your problems. But that doesn't mean you can't solve problems. It means you take it a step at a time and you learn from each iteration, and that feeds into the next iteration. So that's what we talk about in the case of SOA, right? Organizations don't really have all the answers when they start. That's fine. You're working at lower levels of maturity, and as you iterate, you'll get increasing levels of maturity.
Good. And what is the first level of maturity?
Well, wherever you are today. I mean, it depends on the organization.
Second level?
Well, it's up for you, for the architecture team to define. So actually, that's something we'll be talking about in the course. I don't know if I have any of my students here, but that'll be coming up in a few days, where we talk about, defining your maturity model. One of the things you have to do as an architecture team is figure out what is important to you as an organization to measure. So it's not predetermined. It's up to you to decide what is important.
I can continue.
So, but I think you want that ready for the drawing. Everybody put something in there? Okay. So the winner of the book is Ellis. Milas Love. Very good. Congratulations.
Thank you.
Oh, good. You actually looked for it, but you didn't buy it yet. Okay, good.
We will get you the book.
So how are you going to get the book?
I think that I will pass it. First.
You know him personally? Okay.
Yes.
Okay, I'm going to get it to you. Just stop by the training and you can get it to Melis.
Yes, thank you.
Very good. Well, congratulations. Okay.
The book goes to the right person. Yes.
Okay, very good. Well, thank you very much, everybody.
Actually, yes. We will give the presents. We cannot allow it that we